experimenting universal asynchronous receiver transmitter in an ARM LPC2148 microcontroller is the topic of the discussion today. Here the objective is to make use of the on-chip universal asynchronous receiver transmitter for serial communication. So we know the block diagram of LPC2148 ARM7 based microcontroller. In this ARM7 based LPC2148 microcontroller, with respect to universal asynchronous receiver transmitter, we have two universal asynchronous receiver transmitter, which is highlighted in the block diagram, which is UART0 and UART1. Okay, so whenever we talk about universal asynchronous receiver transmitter, okay, so there is something like transmit data and there is something like receive data. So transmit data is represented as TXD and the receive data is represented as RXD. Okay, so among several serial peripherals in LPC2148 microcontroller, UART is one among them, which is highlighted and it is shown in this PPT, right? So better view of this UART is this. So universal asynchronous receiver transmitter 0. There are two universal asynchronous receiver transmitter. Because of two UARTs, you have a TXD 0, which is transmit data 0, and RXD 0, which is for UART 0, and TXD 1 and RXD 1 pins for UART 1. So as you know very well, TXD pins are going out of the microcontroller, which is transmit data pin, and RXD pins are coming inside the microcontroller, which is receive data. Because there is a separate transmission line and because there is a separate receiving line, so when both the transmission and reception happen simultaneously means that we call it as full duplex. So universal asynchronous receiver transmitter is a full duplex serial communication protocol. How to identify whether the protocol is full duplex or half duplex? If there is a separate transmit line, if there is a separate receive line, then that justifies it is a full duplex serial communication protocol. If not, it can be a half duplex serial communication protocol. So what is this DSR, which is dataset ready? What is this RTS? RTS is request to send. What is this CTS, clear to send? What is DTR, data terminal ready? And ring indicator and data carrier detect. So these are all the bidirectional control signals for both UART0 and UART1. If the transmitter is ready, it notifies the receiver through dataset ready. When the receiver is also ready, it notifies the transmitter through data terminal ready. So what is dataset ready? Naanga ready. Abdina transmitter sonna dataset ready. Yargita receiver kita. Receiver enna solno? Naangulu ready. Abdin solno na data terminal ready. So in technical terms, both are powered on. Okay, so transmitter is powered on and it is alive. Receiver is powered on and it is alive. I am also alive, you are also alive, both are there. Then shall I send the data or shall I transmit the data? For that, it will send another control signal called request to send, which is RTS. Okay, anupunga na free is clear to send, which is CTS. So the first loop is dataset ready and data terminal ready. Naang ready, ning ready. Yeah? The second loop is request to send and clear to send. Anuplama, anupunga. Anuplama is from request to send is a signal from transmitter to the receiver. Okay, na free anupungana signal from the receiver to the transmitter. After that, then you go for transmit data and receive data. So through TXD, signal will get transmitted and it goes on. In the LPC2148 datasheet, UART is in the chapter 10, and it says 16-byte receive and transmit first in first out flip-flops. Okay, and register locations conform to 550 industry standard. 550 industry standard. What do you mean by 550 industry standard? I will show it in the next slide. So here you see, this is the 550 industry standard, right? So 16550, there is something like industry standard. According to this industry standard, the ability to convert data from the serial to parallel and from parallel to serial using shift registers. So according to the standard, the serial protocol or the UART should have the ability to convert data from serial to parallel and from parallel to serial using shift registers. On-chip baud rate generated to control the transmit and receive data rate must be there. And handshake lines for control and external modem controllable by the software. Handshake signals and path the data set ready, data terminal ready, request to send, clear to send, etc. Interrupt function to the host microprocessor. Okay, so we have to interrupt the microprocessor that data is ready to be transmitted or transmitter is empty, to notify the microprocessor, we need to set a flag or we need to create an interrupt. And there is a need for on-chip first-in, first-out buffer for both incoming and outgoing data. This is very important. So the buffers will reduce the loss of data. The transmit buffers and receive buffers will reduce the loss of data. Hence, buffers are mandatory inside the microcontroller. This gives the host system more time to respond to an interrupt generated by the UART without loss of data, which is very interesting. So this is the standard, right? 5.5 standard. So the UART inside the LPC2148 supports this 550 standard. According to the standard, as told, the receive first in first out trigger points at first register or fourth byte or eighth byte or 14th bytes. So built-in fractional baud rate generator with auto bauding capabilities. So automatically baud rate generation is also possible in LPC2148 microcontroller. And there's a mechanism that enables software and hardware to flow control implementation. Okay, so these are the simple features of UART in LPC2148 microcontroller. And these are all the registers which are associated with LPC2148 microcontrollers, UART, that is Universal Asynchronous Receiver Transmitter. So we are interested in UART 0. We are interested in UART 0. So there is one register called UART 0 receive buffer register. There is a register called UART 0 transmit hold register. So there is a register called UART 0 divisor latch LSB, divisor latch MSB. So through this divisor latch registers, we will fix the baud rate. And there is something like interrupt enable register, interrupt ID register. So there are few more registers. UART 0 line control register and UART 0 line status register. So in the line control register only, we'll do some initialization. So when the DLAB bit is 1, then only it will enable the baud rate setting facilities. So P0.0's alternate function is TXD0. P0.1's alternate function is RxD0. So default, it will be acting as the general purpose input output pin. It is our requirement to convert this general purpose input output pin into an alternate function. Here the alternate function is serial port, that is UART 0. So we have to convert P0.0 into TXD0. We have to convert P0.1 into RxD0. So for that, we have to go for pin cell register. I hope you remember pin selection registers. The pin selection registers must be properly used. So with this understanding, let us start writing the code, and one by one we can understand very clearly. As usual, we are going to write the C program. Hence, the C program starts with hash include LPC214x.h and void main. And the initialization should happen between void main and while one. So now we are going to initialize the serial port of LPC2148 microcontroller. Hence, the first line of the serial port is we have to initialize the pin cell register, right? Here the pin cell register is 0. Its corresponding value is 0x00000005. So when you write the pin cell register value as 05, then those GPIOs will act as a transmit data and receive data pin for the UART 0. Okay. So after that, we have to set the baud rate, right? So we are interested to transmit the data in the 9600 baud rate. So for that, we have to enter into the divisor latch. So for that, we have to give the UART 0 line control register. So the UART 0 line control register has to be loaded with the value 0x80 to enable the access to the divisor latch. After that, for 9600 baud rate, there is a calculation. Based on that calculation, UART 0 divisor latch load register. In that register, if you load the data with 0x62, it is configured for 9600 baud rate. So UART 0 line control register, you have made it as 03. 03 means when it is 11. It is 11 means 8 bits per character. So the initialization of UART is over. Then, as discussed right now, we have to wait until the transmitter becomes empty. So while UART 0 line status register is not equal to 0x60. So when UART 0 line status register value becomes 60, that justifies the transmitter is empty. That means parallel serial out shift register is empty. Now it is ready to shift out the next data, something like this. So how to send out the data? The data is sent out through parallel serial out shift register. Parallel in serial out shift register in LPC2148 microcontroller is UART 0 transmit hold register. So the data which has to be transmitted serially has to be loaded in UART 0 transmit hold register. And here we are putting the ASCII value 0x41. Okay, this will continuously transmit the data 41. And if you stop the program means the while loop will keep on repeating. So After transmitting A, it will wait for transmitter hold register to become empty. When it becomes empty means the 41 will get transmitted. Then again it will retransmit 41. So it will keep on transmitting 41, 41, 41, 41, 41. And the serial window will keep on displaying A. So which character is being transmitted, that will be displayed in the screen. So it will transmit only the ASCII values. Okay, so if you monitor the screen, transmitting window means the screen window will be filled with A. Okay, the screenshot of the same is shown here. Where if you look at this, the corresponding comments are also being given. And here you can see the bottom right corner, you can able to see A is keep on getting transmitted. So now let us experiment the UART 0 through a demo in a KEIL IDE. So the code which is being written here is include LPC2148.h and void main, and the pin cell 0 is written as 0x00005, and UART 0 line control register is kept as 80. So here by giving it as 80, which is D7th bit as 1. So you're entering into the device latch registers. After entering, we are writing the baud rate value. When you give 62, the baud rate will become 9600. After that, coming out from the device latch by giving 0 in the MSB, and this 3 is 8-bit per character. Okay. So after initializing the serial port, we are coming to the while loop. Inside the while loop, we are waiting until the transmitter becomes empty. When the transmitter becomes empty, you will get 60. When it becomes 60, the condition fails, it will come down, and your 0 transmit hold register is the parallel single shift register. Hence, the value 41 will get transmitted, and this will get repeated again and again. That is what we are going to see now. Okay. So after compiling, so compiled, build and rebuild all. So 0 errors. Going to the debug window, debug start sub session, and in here. So now we are the debugger window. Here the program counter is waiting here, and if you see the serial window of your LPC2148 microcontroller, here there is a line control register. Here can you see line control register, line status register, interrupt enable register, interrupt ID and FIFO first in first out control register, and the receiver and transmitter registers and scratchpad register. So transmit enable register, and transmit hold register, and UART 0 a scratch control register, and divisor latch and fractional divider. This is to set the baud rate. So this is divisor latch low and divisor latch LSB and MSB, and the corresponding resistors associated with divisor latch and fractional divider for setting the automatic baud rate. There is an automatic baud rate control. So these are the different registers and the corresponding bits, which takes care of the entire UART functions of LPC2148 microcontroller. Out of this, we are using only few bits to start with, to begin with. Okay. And this is the UART1 window where we are expecting some character A in the screen. One by one, we will see. The first and foremost requirement is pin cell 0. So let us look at the pin cell registers as pin connect block. If you see, so there is a pin connect block register. So here you can see to port 0.0's alternate function is TXD, P0.1's alternate function is RXD. So default all are acting as a GPIO ports. So when you write pin cell register 0 as 0000 and 0005, then what happens? Pin cell 0 will become, that is P0.0 will become TXD, and P0.1 will become RXD. That is what we are going to see now after executing the fifth line. I am doing the single step execution. I am executing the fifth line by doing single step. After executing the fifth line, the pin cell 0 is loaded with 5. You can see the pin cell register is loaded with the 5. When the pin cell register is loaded with the 5, so P0.0 will be reconfigured as transmit data pin for which is for UART 0, and P0.1 is configured as RxD0, which is another alternate function, which is for UART 0. Okay, so this is the one you need to understand, which is very easily visualized through pin connect block, which is helping us to identify each pin is behaving as a general purpose input pin, or it is used as some of the alternate functions. So to view that, this pin connect block is most widely used. So here we are interested is Our interest is to make use of P0.0 and 0.1 as transmit pin as well as receive pin of UART. Hence, the configuration is correct. Okay. Now UART0 line control register is 80. That means here you can see UART0 line control. You are entering the divisor latch, and you are loading the divisor latch low with 62. Divisor latch here it will be loaded with 62. When it is loaded with 62, the baud rate will become approximately 9600 baud rate that we have to see now. So after executing the single step execution of line control register, which is 80, so now it is enabled, right? So divisor latch is enabled now. So by writing that as an 80, then now we are loading the DLL as 62. So now this will become 62. DLL becomes 62 instead of 1. So you can see the baud rate will get changed to 9600 after executing the 7th line, that you have to understand. So now the 7th lines got executed, and divisor latch low has become 62, and the baud rate has become most close to 9600 baud rate. Okay. Then afterwards, line control register has become 03. So we can see line control register, which is line control register. So this line control register, here it is 80. Now when it will become 03 means word length is 5 bit. It is showing word length is 5 bits. 5 bits per word will be replaced as 8 bits per word because of writing this 03. So after executing the 8th line in the line control register, this word length will become 8 bits. Here you will get 03. Let us see this. After executing the next line, we are able to see line control register is 03 and it has become 8 bits per character. So this is how we have to initialize the UART serial communication. And if you look at the status register, right? So now the next line is, right, you are looking at the status register, right? You execute the next line means we are looking at the status register for 60. Why 60? You see here, default there is nothing is being transmitted. Hence, the transmitter hold register is also empty and transmitter is also empty. So there are two tick marks here. Because of these two tick marks, already the value is 60. Okay, so these are all the 8 bits where every bit has its own significance. So if the most significant bit is 1 means there is an error in receive buffer. And if the 7th bit is 1 means transmitter is empty. 6th bit is 1 means transmitter hold register empty. So similarly, each bit has its own significance. Our interest is to check whether the transmitter is empty or transmit hold register is empty. When both are okay, we are expecting 60. So it's already 60. So the condition is true because it is not equal to 60. Now condition is false, so it will come out from the while loop, right? See, after executing this line, it will come out from the while loop. After executing this line, it will come out from the while loop. 11th line, right? 11th line, the condition fails, right? When it is not equal to 60, it has to be in the while loop. But here it is equal to 60. So the condition fails, it will come to execution will come to the 12th line. You can see execution will come to the 12th line. So transmit hold register value is loaded with 41. So 41 is the ASCII value for American Standard Code for Information Interchange value for capital A. So that A will get displayed in the UART serial window. How to get this UART serial window? So here you can see there is a UART1. Here there is a UART window. So UART1 window, now it has disappeared. Now again coming here, and then you have to select this, and if you click UART1 window, UART1 window will come here. So this is how we can able to see what character that we are transmitting from the microcontroller. So this is one wonderful simulation environment where through the simulation you can able to see what character is being transmitted. Okay, now we are transmitting the ASCII equivalent of 41. So let us look at the ASCII table here. So this is an American Standard Code for Information Interchange table, right? So according to this table, if you see, this is the hexadecimal value, right? When the hexadecimal value is 41, then you can say character A is getting transmitted. That's what I'm telling, right? When we transmit 41, according to ASCII table, its value is capital A. A has to be displayed. So I'm running this code. So A will get displayed here. Can you able to see A here? Can you able to see A here? So A is getting displayed, right? A is getting displayed. So I'm just keep on running this. I have run the code, it keep on running, so it is completely filled with A. So A is getting filled in the entire screen. This is how we have to transmit a single byte of data to UART in LPC2148 microcontroller. Okay, so like this, if we continuously send the ASCII characters, it will get transmitted in the set baud rate. The set baud rate is 9600, or what value that we set. Accordingly, it can transfer the data as per the requirement. Okay, so with that, we are completing our UART serial transmission. So later on, we can see how best it goes in the following classes. Okay, so now we experimented how to transmit the character A in a using LPC2148 microcontroller, and thank you very much.